Welcome to the last video number 4. Now we're going to talk about geometric sequence and series. What is a geometric sequence? We have always the first number and we're multiplying the numbers by a number called R, called common ratio. So here I'm multiplying by 2, 7 times 2, 14, times 2, 28, 56, etc. So the first term is 7, and if I want to write it in a recursive form, any term equal the term before an equal an minus 1 times 2. Here I'm multiplying by 9. So when you multiply by a number bigger than 1, the numbers are increasing. So here I'm multiplying by 9. The first term is 2, and any term equal the term before times 9. Here I'm multiplying by minus half. When you multiply by minus half, the sequence will be beeping, one positive, one negative, or negative, positive, negative, positive. Because if you multiply here by minus half, 48 times minus half, minus 24. If you multiply by minus half, it will be minus times minus is positive. So when you multiply by a number R, which is of the form plus or minus 0 point, the number will decrease at the end to near what? 0. However, here it goes either to plus infinity, minus infinity, or both. So a geometric sequence is a sequence whose any number is multiplied by a constant number called common ratio, which is R. So let us go to the explicit form. You can read this one by yourself. So what concerns me is the property states any numbers an equals, suppose the first number was ak, it can be a0 or ak. Like in arithmetical sequence, it will be r times power n minus k. If the first number was a1, it will be n minus 1. If the first number was a0, so an will be a0 r power n. So this we're going to use it always when they ask about any terms we need. We have the formula like in arithmetical sequence. You can follow that one. Sum of the first finite, the first n terms, is a1 into 1 minus rn over 1 minus r, or you can write it as n. The finite number is a1. If you change up, you must change down. R power n is the number of terms we have over r minus 1. So let us take this example. This is, as you can see, this is a series. 3, 6, 12, 24. So the first term is a 3. And r, I'm multiplying each time by 2. So it will be a1, 3 into, if you want to use this one, 1 minus 2. How many terms I have? They want the first 20 terms. So power 20 over 1 minus 2. Okay, it will be this value. There is a big difference between finite sum and infinite sum. Infinite sum till the end. I want to tell you, let us take these examples. If you're multiplying, for example, here, this is a geometric sequence. You're multiplying by 2, by 2, by 2, by 2. So if you want the sum till infinity, directly it's infinity. Why? Because r is bigger than 1. When you multiply by a number bigger than 1, the number are getting bigger, 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 so till infinity. I'm going to keep 2 till the last one. Number 3, here I'm multiplying by minus 2. Minus 6 over 3 minus 2, 12 over minus 6 minus 2. So as you can see, the number one time is positive, negative, positive, negative. If you want to do the sum, it will be plus or minus infinity, since r equal minus 2 less than minus 1. Here, if you're multiplying by 3, so it continues to the sum at minus infinity. When the sum at infinity is finite, we set up if the sum is finite as n equal a1 over 1 minus rn over 1 minus r. This means if I want a finite sum from a number to a number, but from infinity, if r bigger than 1 or r less than minus 1, always is a plus or minus infinity. However, if r was between minus 1 and 1, you know, it's of the form 0 point or minus 0 point. What's happening to the number? The number are shrinking, like you see in number 2. 2 plus half plus 1 over 4 plus 1 over 8. At the end, it is 0. So you may approximate the sum. Why? Because 0 point power infinity, 0 point times 0 point times 0 point by itself tends to 0. So what will be the sum at infinity if r is between minus 1 and 1? it will be a1 over 1 minus r. But if r is bigger than 1 or less than minus 1, it will be either infinity or minus infinity or both. So that's why here, since r is 0.5 between minus 1 and 1, the sum at infinity is a1 over 1 minus r. a1 is 2 over 1 minus 0.5 is 4. Okay, so always when they want a finite sum, you need to check if r is between minus 1 and 1. If r between minus 1 and 1, you use this formula. However, if you want to find the sum at finite, for example, for 20, first 20, first 50, first 100, first even million is considered to be a finite sum. So you do this formula. Okay, so let us go to problem. Given a sequence, write it in explicit. As you can see, 8 minus 4, 2 minus 1, etc. What do you realize? We realize that minus 4 over 8 is the same as 2 minus 4 is the same as minus half, etc. So this is a geometric sequence whose r is minus half. They want us to write it in explicit form. N bigger or equal to 0, so the first term a0 is 8. So any term divided by the term before is what? Minus half. So an plus 1 divided by an is minus half. So this is the recursive form. The explicit form, it means you want to find the property. We said an, because we're starting by a0, it will be a0, a0 times r power k. a0 is 8. R is minus half power n equal 8, 9. I want the first, find the 10th term. Because I'm starting by a0, the 10th term is a9. So it will be 8 into minus half power 10. So it will be this value. So to understand well what I'm doing, you need to watch all the videos, the video number 1, 2, 3 till 4. So now, which term has minus 1 over 256? So I write minus 1 over 256 equal a0, r power k. a0 is 8, r is minus half. So you can take, this is 256 is 2 power 8. This is 2 cube, cross multiply down. It will be minus 1 over 2 power 11 equal minus half power n. So n is 11. So it's the 12th term. However, if you know the logarithm, you can use, starting from here, the logarithm, or from here. You take this to the other side, it will be minus 1 over 2048 equal minus half power n. So n equal len answer over len base. So directly you're going to get 11. But when you're going to use the logarithm and the calculator, don't take the minus inside the logarithm, or else it will be impossible. So take it as len over len where the numbers are positive. Then they want us to find the sum of the first 7 terms. So it's a finite sum. For finite sum, the first term is a0, rn minus 1 over r minus 1. a0 is 8, r is minus half power 7 minus 1 over minus half minus 1. Since r is minus half, you get this one. They want us to write it in sigma notation. The first 20 from 0 till 19. So 19 minus 0 plus 1 is a 20. So I have a 20 terms here. So I write 8 into minus half power n, which is the explicit form. Then they want the sum at infinity. Because r is between minus 1 and 1, so sum at infinity is a1 over 1, a1 here, a0, not a1. So a0, it doesn't change anything. a0 over 1 minus r. So a0 is 8 over 1 minus half. It's 16 over 3. Another example here, but we're going to start by 1. As you can see, I'm multiplying each time by 3. So r is 3. Okay, r is a 3. It's a geometric sequence. Write in recursive form. a1 is 1 over 3, and any term divided the term before is 1 over 3. And if I want to write it in explicit, this is the formula: a1 power r n minus 1. a1 is 1 over 3. r is a 3 power n minus 1. So this is in the terms of explicit form. Which term? Find the 10th term. So a10 equal 1 over 3. 3 power 10 minus 1 is 9. Okay, so it will be 6561. Which term has value 2187? I put the formula. I cross multiply. 7 to 9 is a 3 power 6. You can use your calculator. So n minus 1 equal to 6. So n equals 6 plus 1. So it's the 7th term. Or you use your logarithm. N minus 1 equal len 7 to 9 over len 3, which is 6. So n is If you take the 1 to the other side, n is 7. They want us to find the sum of the first 6 terms. So the sum of the first 6 terms, it's a formula. A1 Rn minus 1 over R minus 1. A1 is 1 over 3. R is power 6. You do it, you find it. They want us to write in sigma notation the first 20. So from 1 till 20, and you write explicit as it is. They want the sum at infinity. Since R is equal to 3, bigger than 1, so sum at infinity, it will keep going up till infinity. The last problem, they want us to write of the form A over B. Always when you have a repetition, what do? You split the repetition from the original number. So you can write this as 2.1 plus 0.034 plus 0.0034 plus 0.000034, etc. As you can see, I'm going to take this alone. This is a geometric sequence. This is the first term, and R here is what? I'm multiplying by 0.01. So this, since R is between minus and 1 and 1, sum at infinity is A1 over 1 minus R. A1 is 0.034 over 1 minus 0.01, which is R, is 17 over 495. I added to what? To 2.1. 2.1 is, if you multiply up by 10 and down by 10, it will be 21 over 10. If you do same denominator, you multiply 21 by 495 plus 17 times 10 over this product. And if you use your calculator, you're going to get, if you divide that, you're going to get this one. Here, I split it 5.11 plus 0.00237. Then I add, because repetition is a 3, each time 3 zeros. So I'm going to take this one alone. This is a geometric sequence, as you can see, where R is 0.001. So since R is between minus 1 and 1, sum at infinity is A1, which is this one, over 1 minus R. So you're going to get this one. You want to add it to 5.11, which is 511 over 100. If you do same denominator, you're going to get this value. And if you use your calculator and divide this value, you're going to get that one. So this is the sequence. I have explained the sequence in 4 videos. I hope that you got everything, and for any further question, you can ask me anytime you want. Thank you for listening.